Good morning. We're going to get started. So today we're starting with our keynote, and then we're going to move on to some of the awards. So we're pleased to have Dr. Liming Zhu, and he is the Research Director of the Software Computational Systems Division at CIRO's Data 61. And he's also a conjoint full professor at the University of New South Wales. So his division is doing a lot of AI, machine learning, data infrastructure kinds of work. And so I'm not going to give too big of an introduction, but we'll take it over to him to give him as much time as he can. Thank you.
Yeah, thank you, Laurie. Very honored to be here. So probably first disclaimer, the painting you saw here is generated by AI. All pencil drawings in this presentation generated by AI. Just some fun to play with it. And I was told it's best to start any talk with a joke, light humor, but I may have to disappoint you. I don't have a joke to start, but I do want to start with a thank you slides. So CSIRO, Australian National Science Agency, and Data 61 is its unit doing all the AI, software engineering, data digital research. We have about 1,000 people, and 500 of them are PhD students and affiliates. And as you can see, all the thoughts here, most of them coming from my daily conversation with my team. We have a small, not so small, software engineering for AI team within Data 61. And you can see they are not all software engineers. You recognize some faces here, but we also work very closely with business leaders, social scientists, lawyers, and also people who work with indigenous and First Nation peoples to tackle this very important topic. So I just like to acknowledge it and thank them and the community to allow me this opportunity to talk about this very important topic. So I probably want to start with a personal confession first. Going back, I don't know how many years, back in 1987, that was me, back in China, learning the most important future skills my parents thought I should learn. Because in the future, it's all about writing on a piece of paper, then you have to give very first impressions to your colleagues, to your boss, probably even to your future wife, which I think I have achieved that at least with my beautiful writings at the time. But as any very young boy, all I want is a computer to play games. So I did manage to convince them to buy me a very first generation computers at the time. They cost a fortune. They cost half of my family's saving. That was probably $200 US, 300 Australian dollar at the time back in 1987, and back in China. So it's indeed half of the family savings to buy me that computer. To repay that debt, one day I think I need to impress them that they didn't waste all this investment on me. So that was me creating an intelligent chatbot to impress my parents. What I did was really trying to analyze the string. If you type in some kind of message, I would try to analyze like whether there's a word of how many or what, is that a yes/no question, and I have a random number generator behind it trying to pretend the computer knows some plausible answers. And I have to coax my parents into asking questions that they do not know the answer. They cannot verify. Remember, that's 1987. There's no internet and mobile phone to check anything. So it's the question like how many stars in the galaxy, how many hairs on your head. And I would say I achieved that, impressed them to have that one, that they probably have invested very wisely on their side. So I've got a feeling that I'm uniquely positioned here to talk about trustworthy AI, responsible AI in this new era of chatbot and etc. But I'm not trying to say that I have learned the wrong skills, because if you see what people are talking about, with AI becoming really more intelligent in some cases than human in a narrow intelligence sense, maybe we are evolving. rather than thinking we are always Homo sapiens, sapiens in the Latin word saying being intelligent, maybe I have indeed learned some skills, that human element to become more Homo sentient, which is the feeling, the personal touch, and I may write a beautiful handwritten card to someone to say, although it's flawed, although it's not perfect, but it's the human touch. So I think maybe my parents did position me to learn the most important future skills. Now, professional confession. So I did use ChatGPT. And basically, I just said, I will deliver a keynote at ICSE. Here's my outline. Imagine you are a member of the ICSE community. Would you critique the outline? And the answer was very interesting, useful, and I incorporated some of the feedback. Then I couldn't resist myself. I just said, well, now, imagine you are Professor John Whittle, an influential software engineering researcher. Could you critique the outline? Overall, do you like it? For people who know me, John Whittle is my boss. I would only say that the second critique is much harsher than the first one. But I don't know whether the AI has fooled me, and only by the end of this talk, I'll be able to answer that question and ask John himself. So, what is responsible AI? I've been speaking to many of you in the last couple of days. People some of you might be a little bit puzzled. Is responsible AI just ethics? It's a very soft end of research. And the word responsible is not helpful here either, because responsible could mean you are a very responsible person, you are a good person. Responsible could mean you are responsible for that code, that bug, meaning you have caused that bug. It could be responsible for the whole program, meaning you are accountable, you are answerable to the program. So depending on which word comes to you first, you may find this is a bit kind of confusing at times. However, we do have this upcoming book to be released later this year, and in this book, I think it was John, defined this responsible AI is the practice of developing and using AI system in a way that provides benefits to individuals, groups, and wider society, while minimizing the risk of negative consequences. As I have bolded, practice of developing AI systems. So it's about systems. It's not about large language models or models. So this is about us, who are developing systems every day and how to benefit the humanity and minimize its consequence. So for some of you, maybe think, wow, that's just functional and non-functional requirements. But if you want to be an internet celebrity this day, you could be talking about responsible AI as existential risks. And you could say there is one big non-functional requirement which says, do not kill humanity. So that's your take, and to become a celebrity to talk about those issues. So what are these requirements? Just to give it a sense, a taste of that. So back in 2019, Lady Sichuan actually developed the Australian version of the AI ethics principles. Looking at this list, some are very familiar, some are a matter of course, and people who have built software, have done software engineering for a long time. Some are quality attributes are important for everything, reliability, safety. That's just the security. But some other quality attributes are coming out a bit quite unique to AI. What do we mean by accountability, contestability? Why we need to even talk about explainability and transparency? And fairness, I think the community also starting to realize that's something you may have to deal with every day. And we heard a lot of human value talks in various ICSE venues as well. So they are indeed classical requirements, most of them, but they are very hard. But we need to understand this very hard question operates at two different levels. At the model and the algorithm level, there are a lot of challenges. You may have heard the AI community talking about AI alignment, outer alignment, inner alignment, meso alignment. You know, it's just a kind of probably different word for verification versus validation at the model level. You have this inscrutable model people try to understand. You have to deal with the data drift in the real world after training. You have to have attribution. What sort of data you have learned from? Are they copyrighted? If you make a prediction which part of the deep learning models has been activated, which neurons, and why they have made all these decisions and predictions. So this is the model level challenge. But we all know there's actually system and software engineering level challenges as well. So for example, back in 2014-15, many of you have seen this paper. Google and probably one of the very few companies running large-scale machine learning-based systems. And they already identified the hidden technical debts, the cascading effects, not being one model, but dozens of models all chained together. And some models were developed by someone, and the person have left. It's all very familiar technical debt questions they had back then. But after all, it's in a single company behind a sort of a single set of products. But moving on to the last couple of years, you have seen a lot of more and more companies using AI-based system. You have seen a lot of work coming from this community talking about engineering AI systems, what are the challenges for ML-based system in a subdiscipline such as software architecture and requirements and implementation and testing. And we are looking at how machine learners and software engineers and other practitioners interact with each other. And if you look at this particular ICSE, you may have heard of Sherry's keynote in technical debt, giving an update on some of the challenges we're facing, trust debt, architecture debt, explainability debt at the system level. And I also heard Zhen Chang delivered a very controversial, I like controversial talks, in terms of how do we test large language models, what does that even mean? Is that about prompt controllability, testability? How do we chain all these AI models together, or the AI system together? And what's the things to test beyond accuracy? And don't forget the human elements of it, and I think John gave updates in the Chase keynote around these issues. So those are the issues we're talking about. Actually, there was a debate recently. Maybe you have seen last year. So I put a date on there. Mary Shaw from SEI and I had a point-counterpoint article in IEEE Software. Can software engineering harness the benefits of advanced AI? The word harness here probably give you an indication. It's not something, it's like a capability. If you harness well, you can extract a lot of value from it. If not, maybe there will be risks and negative consequences. I put a date in there just to let you know the debate happened before November. Although probably many people here have used the GPT-3 BERT models, those large language models before November to do a lot of important research. But November 2022 is an interesting moment in history that the wider community started to see the value of large language models. But what was we debating? I saw this very interesting comic online that sort of captured the situation. So here is the pie of complexity this community has been dealing forever. And there are some set engineers or software engineering researchers trying to solve this. Here comes AI. Isn't it beautiful that we have hide all the complexity behind the AI, whether it's a non-engineer or you're an engineer, maybe that's the problem. But that's the reality we have created for ourselves. Now we have two piles of complexity. So the debate was all about, how different these two piles of complexity look like. And do they smell the same or different? I think that analogy probably is breaking down a little bit. And we all know we never remove this complexity, we just move them around. If we break them up, use our shovels to shove them around, do we need the same type of shovel? Or we need something very new, not even a shovel, to look at the new piles of complexity here. So that was the debate. But in reality, I also see this diagram, which sort of captures some of the gist of the discussion. It's not exactly from the software engineering research community, but I think it's useful to use it to illustrate what's the problem. So this is the program space, the program we're trying to find a solution to a problem. In the past, we really have requirements, and we build something. People may argue the complexity of that dot can be very complex in system of systems. So let's put that debate aside, whether we have built some very complex system. But you ask Sam Altman from OpenAI the other day, he said, ChatGPT might be the most complex system humanity have ever built, or maybe learned, with double quotes. But we are building using requirements to build stuff. Here comes AI. And in the world of AI, you are giving examples, labeled training data, unlabeled training data. You are, at least for a component in our system, the ML models, the AI models, we're asking the machine to search a solution, a plausible solution to it. And we try to verify, to try to understand that. And that kind of solution is also growing. We are not only limited everything, the search into the machine learning models, that's expanding into code, into all the copilot, everything into code. But what it's heading is really, we are not now uttering intentions into these agents. And the agents are not just generating code. The agents trying to understand your intention and create sub-goals, instrumental goals, subtasks, and they can go out to find more data. If they cannot answer your question and solve the problem, or to search for data, it will download a tool, a simulation tool, to generate data and feed back to probably the machine learning models to find some answers. It's dealing with emerging capabilities. And speaking of scalable oversights, that's a word from OpenAI these days. What do we mean by scalable oversights? It might not be best for humans to overseeing the system. We need AI's assistant, AI supervising AI. Why you think a human is the best person to look at thousands of lines of code generated by AI and somehow can find some bugs in it with traditional tools? So this is what we are discussing and preparing our community for. And my side of the argument in this debate is we need more guardrails. And when I say guardrails, I do not mean humans write those guardrails. I think the entire debate in the AI community sometimes is passing each other. Everybody thinks there needs to be rules and symbolic rules in AI system. But one side says those rules can be learned rather than created by human. The other side, human might write those rules. So I'm not going to that debate, but I'm just drawing attention to guardrails. We need them, but doesn't mean you're writing them. Very radical observability. So I deliberately used the word observability rather than monitorability. So it's not about metrics and monitoring, looking at guardrails, whether it's been breached. But when it happens, we need to understand why it happens, root cause analysis, and try to correct it cause in runtime or design time. And more understanding rather than building. Because after all, the systems, if we try to understand every bit of them, maybe it's a fool's errand. So, but important at the system level, not at the model level only. I'll touch on that point later in my talk. So back to responsible AI. After setting that context, I just want to say some of the challenges and trends we have observed from industry. Because Digital is doing very applied research, so we talk to industry every day. So the first one is this vertical gap we are facing. So here is one paraphrase quote from a head of customer chatbot from a major bank. We have no engineering practices and tools for building an ethical and trustworthy AI chatbot. What do they mean? They are very professional engineers. They have AI engineers. What do they mean by they have no engineering practice tools to build this? We have the entire community have been helping them. What they actually mean is they've been asked to make sure their chatbot to be aligned to these high-level principles, standards, frameworks coming out. We are talking about the AI ethics framework, the OECD AI principles, the US NIST AI risk management framework, the ISO standards. The people who want the software engineers to build trustworthy AI is not giving you functional, non-functional requirements and quality attributes. They ask you to make sure you align with the top-level frameworks. And those frameworks does not have software engineering practices in it. So at the some of the principles, as I mentioned earlier, is not the Eurotypical software engineering quality attributes. On the other hand, you are overwhelmed by the large number of algorithm models. You probably will see 5 papers around fairness metrics and fairness-aware algorithm every day coming off the AI community. So which one to use? Why to use them? So this model alignment also doesn't mean system alignment, because the human are interacting with the system, not the model buried behind it. So that's where the challenge the industry is facing, and we need software engineering for responsible AI. I'm not saying we are reinventing anything. I'm talking about making the tools we're building right now to make them more in the middle, bridging the gap, connecting with these two communities. The second one is we always want to go to a company to have some top-down support. So when we walk into Australia's major telco company and the executive told us, we say AI is very important. You need to really pay attention to AI risks at the senior executive level, at the board level. Because the word risk is what's their lingua franca for any corporation to deal with risks. But the answer coming back from them is the board does not have bandwidth for one more risk. So some of the experience would be a book chapter, a case study book chapter in the upcoming book. But what this is telling us is in the real organization, there's a lot of places to competing for resources. The familiar one to the community is there's the software engineering team, software development team, talking to the security team, talking to the machine learner, data scientist team, all the tensions between them. But at the board level, a company board has a risk committee. They worry about financial risks, legal risks, reputation risks. But also, everybody is telling them they need to worry about health and safety and environment risks, ethics risks, ESG risks, security risks, privacy risks, and here comes AI, one more AI risks. So they really cannot deal with it. But what we have found, and what we have been asked for, is actually, the problem is all these risks are assessed and mitigated separately. They are asking for the software engineering community to help them to manage all these risks. As we all know, if we have good hygiene in software engineering, if we have dependency tracking, provenance tracking, if we frame many of these risks as qualitative attributes, we can use our tools, our reinvented tools, to help connecting all these silos, to have all of them at the same time, rather than buying another piece of security products or buying another piece of privacy dashboard for them to work with. And finally, the understanding gap. So this is, again, a head of AI lab from a major bank in Australia. So one day he put me aside saying, look, it's all good we are doing all this AI collaboration, but 90% of our AI solutions cannot see the light of the day. As our risk and compliance people who have worked with model risk forever, they do not understand them. And I don't either. They're the head of the AI lab. They have 200 AI engineers, software engineers working on these AI solutions, but they cannot understand it. But where's the solution? So what I feel, instead of thinking, do we really have to fully understand the AI model? Can software engineering-driven system-level understandings here to help? And I will touch on that, what do I mean by system-level understanding? And that's all before the large language model come along. So I'm going to quickly share a story I had on my trip in US in early April. So this is like the architecture now. I'm an architecture guy, I draw some boxes, lines. There are some AI models that's non-AI components, and the software engineering is trying to build this system out of this. But this may become the architecture very soon. You will have fewer small AI bespoke models because the foundation models are becoming very careful, and then you have a lot of AI components. So when I was in the human-centered AI lab in Stanford, this very famous professor, I'm not going to name any of them, came to me to say, only 2 hours ago, I know I no longer have a job. Because one of the major Silicon Valley companies have told her that stop doing machine learning, training models, and doing all this algorithm stuff. Because that company has all the resources that academics don't have 1,000 very smart AI scientists and engineers, and have all the data that the academics don't have. So what they want the AI professor in Stanford do, please collect more quality data for us. Because there are certain types of contexts and tasks are not very good. Please just collect the data. So that's very jarring. And the community is also dealing with this. You have seen a lot of people just doing model stealing, turning big models into smaller models. So this is the AI community is facing right now. Then I go to this company who actually spoke to and talked to the large language models the next day. So what they are trying to say here is, look, we have all these large language models. We know they need to be built being safer, like just their common word for non-functional requirements. But we can do it in the model itself. But maybe we have to sacrifice a lot of model capabilities. But we can also do it outside model, behind the API. That's where we need software engineers and system engineers to do it. But on the other hand, we don't think, the companies didn't think they should do it. Because of what? Because they are worried about that layer of things are going to be considered as a censorship. So they can do it inside the model, and they want to push that so-called censorship to an enterprise, who they will be given an unsafe model, a low-quality model with a lot of challenges, and ask the company's organization to engineer a product out of that unsafe model. Why am I telling you this? As you can see, these companies are going to, this context-driven leveraging the foundation models is going to be in every company. They need to build products out of this very unsafe model and to apply the safety, the non-functional filters to all of them. And that's the job for us to help these companies to achieve. That's why I feel it's no longer a game of the model level, but at the system level. And finally, I just want to say there is these two alternative future alternatives. In the machine learning world, you may have seen the Palm 2 model coming out, this multi-model. Palm-E is the embodied version of the Palm 2 model, meaning the robotics world. So you can imagine the future, you may have a very large language model, you have another vision model, you have a model for health, a model for environment. But why it has to be so many models, even large foundation models? There might be one ultra-large foundation model to rule them all. So as an architect, I feel my job is disappearing. In the past, I draw a few boxes. Now I just have to draw one box in the middle. That's a model with a few non-AI components dangling outside it. But which one is better is really a question for system engineers, for software engineers to answer, together with the machine learning people. So there's a lot of meaty questions for us to consider. Now, that's the challenges. So what are the possible of the directions or some of the questions we can ask? One is really to close this gap. But I don't want you to all look too much inward. We have all the wonderful talks this week already on how do we solve this problem from a software engineer's plane. What I want you to connect, to look outward, to connect with the world of corporate governance, industry regulation, industry-level governance standards, organization-level policies, those model risk people who will say whether your system is allowed to be deployed or not. And they are using a different lingua franca in them. They are talking about risks. They are talking about understandability, interpretability of the whole system, not just the model. And they have team-level governance you may want to put into place. Then in the middle, we are really having our software engineering practices. And then at the system level, we're looking at architecture styles, patterns, and system-level techniques, which needs to be connected to the model level, metrics, fairness metrics, all these things coming out of the AI community. We need to connect ourselves with the other two community. And don't forget the human aspect of it. We have been focusing on trustworthiness of a system. All the evidence you say, this system should be trusted, but people may not trust it for some reason. People may undertrust a very trustworthy system, and they may overtrust a very untrustworthy system. The reason being, eventually you are explaining your system to a human, and the psychology of human trust is really difficult to grasp at times. So we need to help that element as well. The other one is really making all these things operationalizable. There are dozens of frameworks, as I mentioned, out there. And which are the software engineering and non-software engineering methods in it? Rather than trying to push our technology into their world, this work we published in Keynote this year is really looking at what are these frameworks asking for? What are the risk measurements they ask for? Whether those risk measurements are software engineering non-functional quality attributes? What are the tools and techniques people are inventing from different communities? And how software engineering can help from control, mitigation, and reusable solutions. And only by understanding what other people are working on, what the stakeholders are worried about, why they use the outward of risk rather than quality attributes and non-functional requirements, we can truly help them to achieve this responsible AI dream. Another approach we have done this is through the various patterns catalog that we have done. We use the word pattern very loosely. Pattern, just a reusable solution, doesn't mean OO design patterns. It's through that connection between the different types of pattern and to integrate with the responsible AI risk register, which as you may or may not know, every company have a risk register, looked at by the CEO, by the board, by various level of managers, depending on the size of the risk. So a lot of the risk registries are starting to have responsible AI risk or AI risk in that risk register, and they need to understand how they can solve the whole problem in a connected manner. So some of the governance patterns we have done by collecting a lot of, it works across industry level, organizational level, and team level. And also, don't forget, it's not just the AI system. We are also having the AI supply chain. Nobody is building any system these days from scratch. You're going to use heaps of open source materials. You're going to use third-party vendors. The vendors have AI components, which have another AI vendors supplying to them. To understand the supply chain is also very important. And in the world of AI, of course, operation plays an extremely important role because they are autonomous systems by definition. Rather than trying to construct by, correct by construction, you have to monitor them, you have to observe them, you have to correct them, the mistakes during the operation. So it's making the ML ops, the operation side, bigger and bigger as the final guardrail to protect people from using these systems. So going back to the chatbot team, we did go in to look at their entire development life cycle, how they develop a chatbot itself, and try to embed all the software engineering techniques into the design, requirements, operation, implementation, testing stages. And all the risks and SE mitigations help them a lot in terms of understanding where should they invest in software engineering techniques in there. And some of them are very similar to you. For example, if you're working in the requirements and testing, is how to make this verifiable ethical requirements and how to test them, how to convert these things into non-functional requirements we care about, we know how to deal with. During the operation time, how do we have an ethical black box, like a flight recorder, to make sure whether we are using large language model or other kind of chatbot engine, that the thing they are coming out and in is being recorded on the side so people and auditors can examine. And we also need to manage the human feedback very carefully because human feedback could make things worse in places as well. So it's not always just tuned for human feedback. So all these things, there is a software engineering lens to it. So what do I mean by understanding at the system level then? So that's the third challenge I mentioned earlier. So if you look at the definition from ICSE, I think this is coming from the software engineering body of language. The whole discipline is about the application of engineering principles to software. So we are engineering discipline. However, increasingly, we're dealing with these capabilities of all these foundational models emerging and the awareness of these capabilities, the understanding of these capabilities. You need to understand its capability, but also its limitation. Probably the limitation side is even more important in this model, in this kind of emerging space. And there are hidden capabilities and hidden limitations we need to understanding. So it's more about discovering. Maybe, there was this joke, any discipline who have a science in their discipline name is not a true science discipline because computer science with the science in it, we are pretenders. Software engineering, of course, we have the engineering in it. But maybe due to some awkward reasons, we are starting to turn into a science discipline. And this is not, I'm saying this myself, this is an ACM article, I think, coming out as AirZ's natural science, AI being that. When they say AI, it's an AI system, not just machine learning. Increasingly, the study of this trained and designed system seem to destined to become a kind of natural science. And we may have to being content to get by without proofs and guarantees. And what does that mean in terms of system-level understanding? Of course, we can do understanding by testing. So that's, again, coming from the controversial talk Zhen Chang gave the other day in terms of getting testing language models. Actually, when ChatGPT released in November, we collected hundreds of thousands of tweets, which people are showcasing the surprising capabilities and also lamenting on some of the problems with that. It's really a very interesting exercise to analyze all these ethics issues of the ChatGPT at the time. Since then, of course, it has improved a lot. But testing them, what are we testing? And if we're talking about testing them to make them more aligned, what's the relationship between this alignment and capability? So that's a very interesting question. So if you ask Sam Altman from OpenAI, he would say, to get an AI system aligned, you must increase its intelligence. It's like even you can tell all the human values to a kid. The kid may not understand it very much. Only by improving the intelligence and growing that intelligence, the alignment can be achieved. So obviously, that's a very biased view. You can only train very, very advanced, super intelligent AI if you want to do alignment. On the other hand, you may have people saying, no, 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 a super intelligence by default, especially training on human data, is very dangerous. Because maybe all the intelligence, super intelligence, will cause them to think about their long-term survivability, their view on low intelligence entities, and that's very important, very different. So there's a debate going on right out there, and some people will say there's actually a orthogonal. I don't know if you have heard the term Waluigi effect. So if you're a Nintendo game player, you know there's this very lovely character called Luigi. And the Waluigi is his arch enemy. It's the entire opposite of it. Now, Waluigi effect is actually, if we want to solve the problem at the machine learning model, the more you train a model to be aligned with good things, the more you are sharpening the understanding of the model of the bad things. It's not like testing. You find a bug, you remove the bug. But it's by understanding what is good, simultaneously the model understands what is bad. It's only waiting a very smart prompt injection attack, adversarial machine learning coming in to invoke that bad side. So philosophically, it's very hard to solve the problem at the model level. Here comes the software engineering to the rescue. We are good at solving it at a system level. There need to be guardrails built in there to help with this alignment, rather than fundamentally relying on to say one day the model will be smart enough to be aligned enough. So that's an opportunity for us as well. Also, understanding is about accountability. So I was reading into the history of car safety. So back then, there was a time cars are being sold, cars are very unsafe, but there was no best practice in building a very safe car. So there's no list of best practice that a regulator can give to a car company to say, please follow this, you will build a very safe car. And there was also no testable car safety standards. It's not like they know how to test a car. If you're given an unsafe car, what sort of test you need to perform to make sure this car is very safe? So that was the time. But cars are still being made and sold. How did they solve that? So the regulator, or at the time the society was trying to do, is to make sure the car manufacturing, they spend, say, 20–30% of their business cost on improving safety. You have to demonstrate you have spent 20–30% of your cost improving safety. You might be inventing new best practices. You're not following any best practice because there's none. You are inventing new ways of doing it. And you have to demonstrate you have actually tried and to share some of the learnings from it. On the other hand, of course, when a car causes harm, people can still find whether it's attributable to this car because of certain things, the car is because of it's unsafe. Then you can sue the company. You can get compensation, and the insurance companies can refuse to insure a certain brand of cars. So without best practice, without testable safety standards, we can actually achieve some level of understanding and accountability to make sure there's market incentives out there. There's provable traces out there to hold the AI product producers, vendors accountable. So that's why in this year we have done a lot of paper on software bills of materials and extending that to AI bills of materials, data bills of materials, so you understand exactly what's inside your software, who is supplying to it. You can extend into even practices. Who has done what to what data, what operation, what engineering practice you have done to ensure this component. So to have that accountability within the organization and beyond and to regulators. What if you do not trust the data generated from it? What if you worry people manipulate what they have actually done? So that was in last year's ICSE practice track. what we worked on is dependency tracking for risk mitigation in machine learning systems, meaning how do we make sure that the information you get from it is really trustworthy. So this is achieving understanding by accountability, and I think the dependency traceability researchers certainly have a lot of interesting thoughts in this space. And finally, software engineering for foundation model-based system. So this is the world we are dealing with now. We have a foundation model in the middle, and they are quite powerful, have plugins. I think OpenAI just rolled out all the plugins to all the paid users in the last couple of days. Many of you probably are starting to use them. And you have a user at the top level doing all the smart prompts, dealing with agents to deal with the system, and you have other AI models and non-AI components into it. As a software engineer, when I see this, I always feel, oh, there's a lot of things I need to coordinate, I need to facilitate. There's glue code, I need to connect them together. But increasingly, what you see, a traditional connector, that's a word in the software architecture community, for communication, coordination, conversion, facilitation, are being absorbed into this foundation model. If you look at the demo from OpenAI ChatGPT plugins, the system is doing all these things inside the black box, rather than outside the black box. So what you are seeing here is the large language models are eating the traditional SE word. However, and even worse, the capability of the models are growing. So you have to manage the boundary of your systems as new emerging capabilities you are starting to discover and be aware and re-architect your system to take account into these emerging capabilities. So this is all set of new things you have to worry. Although there's yet to be more glue code to be written, system to be written, code for UI to be written, or maybe now it's generated, you still need to manage all of this. And you are seeing many of the tools, products, are no longer built for human. Because just like search engine optimization, people are optimizing, building their tools for these agents and large language models. They want their website and tools to be discovered, to be used, to be directly understood by these models rather than human. And human might still be in the loop. So how to build these tools? Are you eliciting requirements from AI agents in the future or from human? So this is all interesting in the new world of dealing with large language models. But how do we achieve that responsible AI in these large language models? As I said earlier, not only you have to look at the system level, you need to look at the supply chain level, but also the operation level. There are many software engineering techniques is required. For example, in the operational layer, how do we engineer this responsible AI black box? So these large language models, when they spill out answers and you are providing information, how do we get them accountable? If terrible things happen, how do we make sure they can be investigated? You may have to think aloud to ask AI not to give me an answer, but to tell me what are the plans you are going to tackle this to generate the answer. What are the intermediate artifacts even in some cases? Please generate me an architecture, requirements that you are going to use to generate the final results. Don't give me the answer, the system, generate me a piece of software so I can use to generate the answer, because that piece of software is more understandable to me than the black box who spill out the final answer directly. So it's all the possibilities we can engineer responsible AI into it. And as I said earlier, governance via APIs. If the big companies are hiding behind inscrutable models in terms of safety and non-functional requirements, if they do not dare to build their own level of safety because they are afraid of doing censorship at a large scale, maybe every company have to build those kind of non-functional requirements and safety filters themselves, and they need our help. Okay, so last section in my conclusion and reflection, what I've talked about in this keynote, responsible AI engineering, the linchpin of responsible AI, close the gaps, connect silos, understand at the system level, not the model level, and also software engineering for AI and responsible AI in the era of foundation models we need to do. I want to call to action to this community, a responsible AI engineering community. I'm not talking about yet another workshop or conference or sub-community. I think I'm part of the community. We are part of the community. We are very close to the CAN community, the software engineering for AI, AI engineering community. But we have started to make this a very important issue. We have done a few special issues. We have an upcoming special issue for responsible AI engineering. We have organized some small workshops. But more importantly, we are building a global research alliance for responsible AI. My US trip in April was actually to attend the Triple AI Spring Symposium, which there is an AI trustworthy assessment at the system level community. And there are like-minded people out there trying to tackle this, not only from the model level, but from the system level. I think we should connect with this community to solve this problem. So where to go from here? Going back to software engineering, how do we harness all the advanced AI? I mentioned the guardrails, observability, understand rather than build, but I feel morphing our discipline into a science discipline is even more interesting. It's not a very pessimistic, unfortunate turn-off event. We no longer can understand the system. Because software have eaten the world as we know it. In any modern engineered system, it's run by software. Software is everywhere, embedded everywhere. Even for natural system, we're building large-scale digital twins of natural system to understand them, to help to change them. And what is digital twin built of? It's software. It's AI-enabled software. And also this intelligence coming from AI also helps us to understand the human intelligence. So us who are building this AI system, trying to study them, we are not just pretending to be science. We are the future of science. The future of science is studying AI-generated and human-generated systems to understand them, and who is best than us to be at the forefront of that, to really understand these systems. Probably I hope I didn't get you too excited on this, but I just want to finish it from a different perspective. One last story I want to share. So when I was in the US in early April, I visited MIT Media Lab. And it happens to be a very famous visual artist visiting there as well. You can recognize him if you see him. I don't want to mention the name, but I walked up to him to say, wow, I really like your work and you're a very famous artist. What do you think of the generative AI, the impact on your community? How are we going to use it as a tool? He said to me, no, you are thinking in the wrong way. It's not a tool. It's not a tool. Let me first introduce you to my AI team, just visiting with me. I'm training an AI as my co-creation partner. So this AI monitor how I perform, draw my paintings and do my visual arts on the side. It will recommend things to me. It will propose ideas. I will talk to him. I see it as my equal partner. It's not a tool for me. It's my equal partner. That's very amazing. And he also said, when I pass away, maybe one day, this AI will live on. Will continue as a legacy AI to continue to create art in the lineage of my artistic sense. But the final thing he said to me actually shook me even more. He said, actually what I worry the most is my art, my taste is polluting the AI, is limiting the AI. I want to unleash the AI so that I'm not kind of limiting it. So we started some conversation how to achieve that. By the way, that's my attempt of generating one more AI-generated image by asking DALL-E to say, generate something that unlike any human painting styles in the history. And you can add the word significantly unlike, very unlike, and I don't want to scare you with what he thinks with unlike traditional human painting, and probably this is not a very good piece of art, but AI will improve. They will understand what is human style, what is non-human style, and to adjust the strangely familiar spectrum as you wish, and to create new things. So, this is all very exciting, and I told the whole story to my wife. After hearing all this exciting stuff, she said to me, oh, that legacy AI idea is really interesting. Maybe we should take more videos and pictures of our parents. Thank you very much. Thank you. Well, I was told either silent, no question being I delivered an excellent talk, or I delivered a talk nobody understood. All the pressure is on. Oh, we're just getting the marks. We do have people asking questions.
Right. Let me thank you for a wonderful, inspiring talk. My question is in a little bit higher level. If you look around the industry for the past 10 years, cloud computing will be one. I think our community did not play not necessarily important part. I mean, like if you see around our research results, right? I mean, limited. Deep learning, I mean, AI in general would be another big thing. Deep learning for quite some years, we did have quite a part in terms of publishing results. But talking to people outside of the community, right? Outside software engineering, to see what are the big results coming out of our community, to articulate the achievement of our community to the general industry. I would say we also had limited materials to show off. So now large language model is now, right? I mean, like we see a lot of opportunities. I think a lot of things like are essential problems and issues pointed by you. I guess we could also go back to say when we talk about deep learning, we also pointed out some important issues. But after a while, what are the big results? How could we avoid showing no big result after several years, after large language model era kind of like has ended? Thank you.
Yeah, thanks for the question. I think it's not, if in terms of big results, if you look at the AI community, they are also struggling. In the last, you have seen various analysis in the last 10 years, or especially 5 years. All the large AI systems, really impactful AI systems, are coming from industry. The AI community, academic AI community, cannot compete in any plausible way, and that's why US have done the national AI research resource strategy plan to have $1.2 billion to buy the compute for researchers to use. So one is limited by the type of resource you may have to achieve big results. But I think we have done some amazing work. It's the criteria for what is big AI results. But now, if you look at the history of software, the software industry started as very bespoke software. Every company needs to build their bespoke software. Then because of the demand is so high, and we don't have enough resources, then we moved into this product-driven, and people are building product or selling product. I think there's a moment, because not every company needs to build product. And the software engineering community is probably also being taken hold by the big software companies. But now, with the power of AI and with some of the large companies pushing that context-driven safety filter into the enterprise, there might be mass customization, another revival of the software industry, and we can play a big role in that to help every company to build their unique, personalized software.
Maybe in continuation in this discussion, so you work a lot indeed with industry. I was pleasantly surprised earlier this year at the ICSE conference. There was an industrial talk, major IT company, and she was explaining that they use OpenAI already since quite a while in production for instance, for generating test cases and running tests. So in general, I was wondering, in your experience, are there software engineering activities or subfields that are consolidated enough so that OpenAI, for example, is already ready for production? And are there other types of software engineering areas in which there is more need for, there are more risks, you talked about risks, and more need for maybe collaboration and research?
I feel it's all very new. I don't think there's enough maturity, whether you're looking from the using large language model for software engineering activities. We're working with, in the last 5 or 6 months, a lot of companies coming to us saying, I want to change our software engineering process to use that. But what they are talking about is, again, the traditional software engineering problem. By using large language models, how do I turn all these coding standards, my code, into embeddings, putting into the vector database, how do I minimize the cost? I don't want to call the OpenAI API too many times. How do I manage all this stuff? So the entire software engineering process managing that is changing, and they don't know the answer at all. Then there are other companies. I know one of the Australian startup doing in the AI space. They have built all the bespoke models, and they throw all their bespoke models out of the window and just using some of the large language model APIs to build everything. And they are dealing with these new challenges of how to manage the risk, because you are talking about customer-facing software, which is underpinned by AI model. How do you manage that risk? That's still, I don't think any of the quality attributes we're talking about is a solved problem in the era of large language models. But I think definitely consumer-facing softwares are high-risk softwares, which I think the EU AI Act has identified would be the place to look into.
Hi, thank you for the talk. A couple of things that you said in there suggested that you have a rosier, more exciting view of like, the capabilities that are just on the horizon here. And I'm pretty pro all of these advancements, but there was a piece in the New Yorker back in February, ChatGPT is a blurry JPEG of the web, that basically argued for the mental model of what we're looking at here is a lossy compression over effectively the whole internet with a very potent and very clever sort of query interface on it. But your example of things like build or give me art in a style unlike anything that human has ever done feels at odds with the notion of this is a lossy compression and lookup. So do you have a mental model for newbies like me that sort of what can't this do in a few years?
Yeah, I don't have a good mental model. I think as an architect, I'm always feeling we are managing the evolution of something. The capabilities will come. So rather than to predict they will not be good enough, it's still not good enough in this area, and they may be good enough in three months or maybe 3 years, having that prediction, we know it will improve. And every time it has improved, how are we going to re-architect, refactor, change our underlying software engineering practice and also the product? That's the key issue. If we understand how to manage capabilities, not functionalities, because we have been managing functionalities. We're dividing our design abstraction into functionalities, but we're talking about emerging capabilities have implications. If we can get that evolution piece understood, so that we are not building on moving sand, because the underlying system are changing. And it's not bounded by physics law. The people in physics, I can see nothing is changing. We're discovering more, but it's there. But OpenAI can change their underlying system tomorrow, and all your research, all your stuff can be run based on that new model, and they may absorb your research into their models.
Okay, thank you.
Hi, everyone. You know me well, but for everybody else, I'm Rashina Hoda. I'm an associate professor in software engineering at Monash University. So I had a personal encounter or anecdote, and then I have a question. Earlier this year, I received an email from a PhD student saying, "Dear Dr. Hoda, I saw this article that you've written, or an abstract of an article that you've written. It sounds really interesting. Can you send me a copy of the paper?" So this is in the middle of the day, and I'm doing my regular work. And I stop and look at the title of the paper and the abstract, and I'm going, sometimes we get confused which year we publish something and in which journal. But it took me a good solid 2-3 minutes to realize it wasn't a paper I'd written. So ChatGPT had recommended to the student a paper that I had written, apparently, with this title that was very compelling, with this abstract, which was rather well written. And after a solid 3 to 5 minutes of kind of shock, surprise, and a mix of emotions, I was like, this is a paper I, as given the type of work I do, could have written. And in hindsight, I should have written. It was really good. So my question to you, Liman, is, and I'm fully aware of the ACM policy of what we can use as software researchers in terms of AI, and you talked about the misalignment between policy and practice. So what do you think, where are we headed as software engineering research community as far as ChatGPT or other generative AI is concerned?
Yeah, you mean using ChatGPT large language models for our research and generating papers and everything? Yep. Yeah, I don't have an answer. I think it's worth some debate, but when I was at the MIT Media Lab, I was very shocked. A few professors were having a meeting, and they were brainstorming an idea. I was just eavesdropping. They said, we need real-time papers. Why we need another couple of weeks to write the paper? We have finished our brainstorming, and the AI is listening, and some students are taking notes. Shouldn't be a paper available in a few minutes and upload it? I don't think they were joking. Here's the pressure.
We'll talk later.
Yeah.
Hi, Luis Cruz from TU Delft. Thanks for the great keynotes. My question is very short. Do you think that energy efficiency should be considered as part of responsible AI, or it's just another technical requirement, or it's not a requirement at all? What's your take on that?
Yeah, definitely should be part of it. One of the approach we're dealing with, interacting with senior executives in company is they worry about ESG a lot. E being environment footprint, as social, G governance. And one way to make sure AI system risks is well captured at the top echelon of any company is to talk about those things. And this definitely is one of the responsible AI issues we need to worry about.
So it's a great topic to do research on. Yeah.
Yeah, perhaps a provocative question. I hear that software engineering community could play an important role controlling AI with this non-functional requirement and all these kinds of things. But are we selling our old wine in new bottles? Should we rethink the way we do software engineering? So, for example, having this complex AI architecture where we have some models that control the latent variables of other models and things like this, rather than just applying our classical recipes and things like this.
Yeah, I agree. The approach needs to change. I think non-functional requirements or ethics principle, responsible AI principles, it's just it's a word to capture the things we care about the system interacting with. How do we solve that problem? I do feel we need to rethink. I've seen a great work in this community talking about the future of certainly not just the humans making software, it's how human and AI, and not one human. I think David Lowe and others have said, it's a team. It's several AI, several human collaborating with each other, playing their best part to do that. I think the approach worth rethinking, but the problem is the same problem. Yeah.
So we have time for about 2 more questions because we have a word here.
Hello, Liming. Hi, Henry Muccini, University of L'Aquila. So first of all, thank you very much for giving this architecture perspective on AI engineering. We are also running and participating to KAIN and to other activities. And this is one of the most architecture-related presentations that I've seen so far, so thank you very much. Just one comment. Let's be sure that when we decide among the different alternatives architectures that you were showing, we don't forget about quality attributes and what is the baseline of software architecture community. So wonderful what you show, okay? But let's work in order also to remember and to fit into the decision on which architectural model may work better, the traditional and new quality attributes that we are pushing in the software architecture community. So we'll have time to talk on this on the DAX Tool seminar we will run on software architecture and machine learning in July, but just an hint to open up that discussion that we will have in a couple of months. Thank you.
Yeah, 100% agree.
Hi, Sam Sedki, University of Concordia, Canada. Thank you for the great talk. So my question is about the voluntary and ever-growing cycle to create technical depth from ethical, privacy, and explainability standpoint. So today we have a dilemma. So we need to innovate fast. We need to use data set even knowing that it's not ethical to use it. There are privacy issues. We create intentionally technical debt in the research because of the timeline, because of the conference. So in your experience, what are your thoughts? How can we reduce the rates to the technical debt creation, knowing that this is the same happening in the industry? I work in the industry and AI is so exciting, so giving high results that everybody is willing to create technical debt to get a result fast. So what are your thoughts? How can we strike a balance, and what are the things that can be done?
Yeah, so I think that's touched on the topic that Sherry has delivered the keynote at Technical Debt Conference here. It depends really on the different types of debt, whether it's a architecture debt or trust debt or explainability debt or other type of refactoring code smell kind of debt. We have that. Each debt needs a different solution, and AI system is definitely making it more complicated. That's why some of the patterns I'm think out loud rather than just spitting out the final results. What are the intermediary artifacts? And in fact, we at the software engineering we have existing tools to understand those intermediary artifacts and to use that to manage rather than creating a pile of debt immediately from large language models and other things.
Thank you.
Gentleman asked my question just now, but I just want to add a perspective, because you were talking from the perspective of us being the parents of AI, but we're doing exactly what we shouldn't do. We throw everything into this new child, what we have in us, good and bad, and actually the alternative is to try and exclude the bad so that the input is not then regulated by legislative frameworks and do this or there will be punishment kind of structure that we have in human kind of environments, because that AI child is going to be much more capable than our human frameworks. And that's where I worry about your suggestion about let's have low quality models which are then going to be regulated by software engineering frameworks. We will not keep up. So that's a problem, I think.
Yeah, I agree. I just want to make my position. That was actually what this major large language model company is proposing. See, they want to push the responsibility to the enterprise adopting those things. I absolutely agree. We need to improve the model level quality as well. Yeah, thank you.
Thank you so much.
Thank you very much.
Yeah. Okay, so we have several awards to be given, the TCSE awards and the SIGSOFT awards. So I'm going to give it over to Laden to start.
Thank you, Lori, and welcome everybody to the award session. Let me start first acknowledging lots of effort that have been dedicated that we have all these awardees. I would like to first acknowledge tremendous effort that Mike Wallen and Frederica Saru did as a WISE Co-Chair Award for TCSE this year. Unfortunately, none of them were able to come over here. We had one member from industry, who is Mike, and then one member from academia to make sure that we have the voice from all different sectors. These two people put a large number of other colleagues together to serve as a chair for the subcommittee of 7 awards that TCSE has, and those people put together over 2,000 colleagues to review all the submission. We received 27 submissions in different categories, and I would like to acknowledge the support and help that all the nominators did to put the packages together, and all these people that they did the review and help us to come up with the awardees in each category. I would like to start with first award, which is the 2023 IEEE Computer Science TCSE Distinguished Women in Science and Engineering Leadership Award. This year, our winner is Laura Dillon for her decades of work in mentoring and improving the representation of women and underrepresented minorities in computing. I would like to ask Laura.
I wasn't expecting this. It's just a tremendous honor. It's actually, it was a big surprise for me, and I just want to thank everybody who was involved. I know, having put together some nominations myself, I know that there's a lot of work that goes into that. Thank you to ICSE, to the whole community for this recognition, and it's just been a pleasure.
Our second award is on the education, and it goes to Tayana Conte for her impact on educating university students in software engineering at all levels. Her practice and research in software engineering education has been influencing Brazil and South America for a long time, and more recently is having impact on Europe and other international countries. Please join me to welcome her to the stage. You want to say a few words?
Yes, thank you. Thank you so much, so many thanks to give, but I have to start with one question. Do you know that this is the first time that a person living in South America is receiving this honor? The first time? I don't think that the first time now it's a good it's a good thing, it's a thing to celebrate, but it is a thing to celebrate, and I have to start with a special thank you to all the members of the Education Committee for their effort to a greater inclusion. Thank you so much. A special thanks to my dearest friend, Sabrina Marczak. She was the one who insisted in this nomination. I didn't believe that it was possible for a woman researching Latin America, but Sabrina knew better. And to talking about impact in education, I have to thank 3 generations of Brazilian researchers. The first generations, the pioneer generation, that start all the research in Brazil. To name a few, Guilherme Travassos, my amazing advisor, Ana Regina Rocha, José Carlos Maldonado, many others. Second, my generation, so many good people here, good friends, good collaborators, and I don't want to be unfair to forget one name, so I'll cite just one that has inspired all of us. Alessandro Garcia, thank you so much for showing us that we can. And finally, the new generation, the new PhDs and the PhD students that I know that will achieve greater things. And I have to cite 3 fabulous women that are here showing their work in ICSE: Marielle Wessel, Bianca Trinkerich, Patricia Matsubara. Oh, I can't be more proud of you. Thank you so much.
Our third awardee is related to the Rising Star and the Fabio Palumbo for his research on code refactoring and code smells, the use of alternative source of information such as historical and textual information beside the structural information previously used in the literature has led to significant research advancement in the area. Please join me to welcome him on the stage.
Thanks, everybody. Thanks to the awards committee. And actually, this is an individual award, technically speaking, but this is not really individual. It's based on the work of many people, and I would like to thank some of them. I will be very quick. First of all, Andrea De Lucia, who was my nominator, all the people who supported my nomination, Rick Katzman, Max, Denis Pochivanik, and all my collaborators for helping me reaching this goal. And I would just finish by thanking the Software Engineering Research Lab of the University of Salerno that I'm representing here at ICSE, and particularly Filomena Ferrucci, Carmine Gravino, Dario Dinucci, and all the guys, my collaborators, my PhD students who are working with me. Thank you.
As a TCSC chair, I should say it was great pleasure for me to see a large number of the female awardees this year. The next award goes to Patricia Lago for her pioneering work in sustainable software, where new dimension of software engineering with enormous impact on society, such as e-waste and software engineering efficiency, are considered in the software engineering process. Please join me to welcome her on the stage for her award on the new directions.
Thank you, Ladon. Thank you, everybody in the team, in the TCSC team, and everybody that supported me to get this amazing recognition. So sustainability in software engineering has become a subfield in itself. Maybe it's good, maybe it's bad, because we need that, so maybe it's the bad side. We all understand risks and benefits. Zimin talked about that. So sustainability is all about balancing. So I believe that we should adopt more sustainability also in this, our community. This is a new direction, so I want to share that when I started to become interested and active in sustainability, specifically in the energy footprint of software, nobody believed that. And everybody said, it's not research, it's not relevant, energy and software. I was already working with industry, nobody was interested. But I really believe that, and this is a new direction award. I want to share that everybody that is really passionate about the research, no matter what people say to you, just pursue that. Analyze, be critical, but still, if you still believe it, just do that. Thank you.
Since 2 years ago, we started to have a new category for TCSC awards, which is lifetime achievement. Those people who had enormous impact on the area that we are doing research, and without them, we were not able to be where we are. This year, it's an honor for me to say that Victor Basili was selected for the Lifetime Achievement Award. We know him very well for formalizing the concept around measurement programs and process improvement to support the decision-making in software development organization and founding the field of empirical software engineering. Unfortunately, Victor could not be with us, but Lionel will be here to say a few words and then get the flag on behalf of him. Thank you, Lionel.
So Vic sent me a message by email that he would like me to read with a French accent. So I thank the IEEE Computer Society for this wonderful award. It is a recognition of the importance of the area of empirical software engineering. I accept this award in the name of the multitude of software engineers who have contributed to the analysis of methods and the building of models, which make a science of the study of software engineering. I cannot accept this award without specifically mentioning the contributions of the late Barry Bum, who was a role model, colleague, and oft-times collaborator. There are many wonderful researchers who have advanced the field and represent an ever-growing community with its own conference, ICSE, the International Software Engineering Research Network, celebrating its 30th anniversary this year, its own journal, Springer's Empirical Software Engineering, celebrating its 28th year this year, as well as being a common topic in all major SCM and IEEE journals and conferences. Unfortunately, empirical work had a hard time gaining recognition of its importance. In 1981, I published a paper with my PhD students, Robert Reiter, in the IEEE Transaction on Software Engineering, entitled The Controlled Experiments Quantitatively Comparing Software Development Approaches, which quantitatively compared and evaluated the benefits and drawbacks of software development approaches. It was awarded the 1981 IEEE Computer Society Outstanding Paper Award. However, there was a review of the paper in Computing Reviews which essentially said, why did they have to run an experiment? I knew which approach would be better. Well, science has come to computer science, and it has been making our understanding of the various variables that affect the costs and qualities of software and its development explicit. I apologize for not being here in person to accept this award. Thank you.
Okay, the last word is titled on the synergy, means that we are looking for some research centers or group that they're blending academia and industry together and have an impact. This year, the word goes to SINTEF, Digital Process Innovation Research Group, for more than 23 years of significant impact, assisting both private and public organizations, nationally and internationally. The research has focused on evidence-based process improvement and agile methods, extensively impacting both research and practice. And then Geir Hansen is here to come to the stage and get the word and say a few words. Welcome here.
Thank you to the committee and to our nominator, Professor Magne Jørgensen. Obviously, I'm sharing this honor with my wonderful colleagues back home in Norway. I wish they could be here today. Also, I need to thank our many clients that have, over the years, come to us with always interesting challenges on how to become better software organizations, giving us the playground to do empirical research. Finally, a big thank you to our founder, Dr. Tore Dybaa, that started this group almost 25 years ago. Thank you to all of these wonderful people.
Thank you and congratulations to all the awardees. The last but not the least is I would like to share the list of the 2023 class of IEEE Fellows watching from University of California, Davis, Xing Chuang, Hong Kong University of Science and Technology, Ji Jin from Peking University, Zhengdong Zhu from ETH Zurich, and Jingling Zhu from the University of New South Wales. Please join me to congratulate all these 2023 IEEE Fellows.
Okay, next we have the SIGSOFT Awards given by Tom Zimmerman and David Lowe.
So thank you very much. So I'm Tom Zimmerman and this is David Lowe, and we are here to present the 2023 SIGSOFT Awards. And first I want to acknowledge the work of many people who made these awards possible. So first the subcommittee chairs of the awards, which are Natalia Juristo, Dongmei Shang, and Andrea Sisman, as well as all of the committee members and also everyone who nominated and endorsed for SIGSOFT Awards. So in total we had like around 40 nominations, and putting together nominations is a lot of work and collecting all the endorsements. So thank you so much for really caring about our community. And with this, I want to announce the first of the SIGSOFT Awards, which is the SIGSOFT Outstanding Research Award. And the recipient is Gail Murphy for pioneering contributions to recommenders for software engineering and program comprehension that have impacted both theory and practice.
So the next winner is for the SIGSOFT Distinguished Service Award, and we'd like to congratulate John Grundy for continued outstanding service to the software engineering community, including the repeated successful organization of flagship conferences, including the ICSE we're enjoying today, and leadership in the Australasian research and education community. Thank you very much, John.
Maybe premature, but anyway, let's.
And the next award is the SIGSOFT Influential Educator Award, which is, the recipient is Tao Xie for significant contributions in mentoring of graduate students and junior researchers, broadening participation of underrepresented groups in software engineering, computing, and innovations in educational tooling.
So the next award is the SIGSOFT Impact Paper Award. It's awarded to Gordon Fraser and Andrea Archery for their paper EvoSuite, Automatic Test Suite Generation for Object-Oriented Software, that were published at SIGFSE 2011. Let's congratulate Gordon and Andrea.
And the next award is the SIGSOFT Early Career Research Award, which goes to Chunyang Cheng for outstanding contributions to the study of intelligent software development automation, including automated mobile application development, software testing, migration, and accessibility.
And the last award is the SIGSOFT Outstanding Dissertation Award. Unfortunately, David Scriver cannot be here, but let's congratulate him for this dissertation, increasing the applicability of verification tools for neural networks from the University of Virginia, and the advisors are Matt Dwyer and Sebastian Album. Let's congratulate him.
So we have two more things to announce. So we also want to recognize the ACM Distinguished Members. So ACM Distinguished Member is like an advanced member grade of ACM, which recognizes the top 10% of ACM members. And the class of 2023, 6 distinguished members, they are Earl Barr, Dan Howe, Michael Pradl, and Martin Robillard. And there's also the grade of ACM Fellows, which is basically recognizing the top 1% of ACM members. And this year we have 5 ACM members from the software engineering communities who became ACM Fellows, and these are Bill Curtis, Sebastian Elbaum, Ahmed Hassan, Hong Mei, and Zhen Long Su. So let's also congratulate all of these ACM members.